Hi, my name is Michael, and welcome to our session on the climatic and humanitarian impacts of nuclear war. I'm excited to introduce Dr. Alan Robock. Dr. Alan Robock is a distinguished professor of climate science in the Department of Environmental Sciences at Rutgers University. Professor Robock has published more than 400 articles on his research in climate change, including more than 260 peer-reviewed papers. He serves as associate editor of Reviews of Geophysics, the most highly cited journal in the earth sciences. His honors include being a fellow of the American Geophysical Union, the American Meteorological Society, and the American Association for the Advancement of Science, and a recipient of the AMS Jule Charney Award. Professor Robock was a lead author of the most recent fifth assessment report of the Intergovernmental Panel on Climate Change, which was awarded the Nobel Peace Prize in 2007. Today, Dr. Robock will be discussing how nuclear war might lead to a nuclear winter and global famine. As with previous sessions, we invite you to use the swap card platform. On the right-hand side panel, please feel free to share your thoughts on the live discussion board. And in the questions panel, please leave and upvote any questions for Dr. Robock to answer at the end of the presentation. After the session, we invite you to use swap cards to set up meetings with your fellow conference attendees. Dr. Robock will also be continuing his Q&A on Gather for about 30 minutes after the session. Without further ado, please welcome Dr. Alan Robock.
Thank you very much for inviting me to make this presentation. If you could show my slides and let me know if you can see them. I'm from, yes? Are they there?
We have your slides.
Okay, great. I'm from Rutgers University, which is a state university of New Jersey. It's older than the United States. I just wanted to first of all, acknowledge that Henry Rutgers, after whom Rutgers was named, owned slaves, as did many of the early presidents of Rutgers College, and slave labor built our campus. The land on which Rutgers sits was stolen from the Lenni Lenape natives. Rutgers is a land-grant school. What that means is New Jersey was able to sell land taken from Western Native Americans for the benefit of Rutgers. And so we just want to acknowledge that we understand this past history and are trying to consider it and improve things. So I started working on this topic in the 1980s, and these are me with some of the other old guys who worked with me at the last American Geophysical Union meeting in December. It's Rich Turco, Brian Toon, and Tom Ackerman, who wrote the first paper on nuclear winter, and Georgy Stanchikov, who wrote the first Russian paper on nuclear winter. But we have a big project funded by the Open Philanthropy Project, and we're working with a lot of younger people too, including Cheryl Harrison and Nikki Lewandowski, who are oceanographers, Lily Shah, who's working on crop modeling, Julie Lundquist, who's working on urban fires, Mike Mills and Chuck Bardeen and Josh Koop, who are working on climate modeling, and Jonas Jagermeyer, who's a crop modeler. Here's the story. Here's our beautiful planet, but after a nuclear war, it might look like this, with a cloud of smoke covering the Earth, starting in the Northern Hemisphere and covering the whole world. If there was enough smoke, it would block out the sun, and it would become cold and dry and dark at the Earth's surface. It would also destroy ozone, and so there'd be more ultraviolet radiation eventually. And this would cause crops to die and global famine. The amount of climate change would depend on the amount of smoke. A war between the US and Russia, even today, could produce nuclear winter with temperatures below freezing and basically global famine. Here's a history of the number of nuclear warheads on the planet that have been deployed. And you can see that during the nuclear arms race, it was going up and up. Then the arms race ended, and the number's been going down ever since then. And so there are 9 countries with nuclear weapons. This just shows the US and Russia, the other set, who have more than 90% of all the weapons. Why did the nuclear arms race end? Well, Paul Crutzen and John Birx wrote a paper in 1982 pointing out that there would be a lot of smoke from nuclear war and it could cause climate change. Then the next year, a Russian group, Alexander F. and Stanchikov, and an American group, Turco, Toon, Ackerman, Pollack, and Sagan, showed that the temperatures would get below freezing and there would be nuclear winter. And the next year, a couple other American groups, including me, did further model calculations, supporting the nuclear winter result. And then the arms race ended. Now, there are other theories about why this happened. One of them is that the Soviet Union ended, but the Soviet Union didn't end until 5 years later. So that was long after the arms race had ended. And I also wanted to point out that the number today is not zero. There's still about 10,000 deployed nuclear weapons. How do I convince you that our science informed policy? Well, the two people that made this decision were Ronald Reagan and Mikhail Gorbachev. And Reagan, in a New York Times interview, said a great many reputable scientists are telling us that such a war could end up in no victory for anyone because we wipe out the earth as we know it. If you think back to natural calamities back in the last century, in the 1800s, volcanoes, we saw the weather so changed. There was snow in July in many temperate countries, and they call it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with the whole nuclear exchange, a nuclear winter? Gorbachev, in another interview, said models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was a great stimulus to us, to people of honor and morality, to act in that situation. And Gorbachev and Reagan almost agreed to completely end nuclear weapons, but they didn't. But the arms race was over. They saw how crazy it was, and the numbers started to go down. That was a long time ago. Why am I even talking about it now? So I want to ask two questions. Although the Cold War and the arms race are over, could the remaining nuclear weapons still produce nuclear winter? And as I mentioned, there's 7 other countries with nuclear weapons now. What about if a much smaller number of weapons were used in a regional nuclear conflict? And the answers are, yes, we can still produce nuclear winter, and it'll last for many years. And if there was a much smaller amount, it wouldn't be nuclear winter, that is, the temperatures wouldn't get below freezing in the summer, but the direct effects would be horrific, and you could still have severe impacts on global agriculture and food for a decade. So during the first nuclear war, the United States dropped an atomic bomb on Hiroshima. It had the explosive power of 15 kilotons, 15,000 tons of TNT, and it killed about 150,000 people. That's 1% of a megaton. And our current arsenal is still so powerful that if you divided it up into 15 kiloton weapons and started dropping one every 2 hours for 75 years, starting after the Hiroshima explosion, we still wouldn't use up our current arsenal. This is the airplane that did it, the Enola Gay, and this is a mock-up of the bomb, the uranium bomb that they dropped. That's me back when I had hair and it was black. This is at the Air and Space Museum. And this is the mushroom cloud by the bomb. And 3 hours later, there was a pyrocumulonimbus, a cloud of smoke from the fires that were started. And it was the fires that were very destructive and pumped smoke up into the atmosphere. This is a drawing done by one of the survivors of Hiroshima, remembering the fires. This is another one showing a streetcar burning on a bridge just under where they dropped the bomb. And here's another one from the Hiroshima Museum showing a department store on fire. This is what Hiroshima looked like afterwards. All the buildings burned and went up in smoke. And it's the smoke and the climate change from the smoke far away from the direct effects that I want to talk about. 3 days later, we dropped a bomb called Fat Man. It was a plutonium bomb. This is a model of it in the Nagasaki Museum, and this is what the mushroom cloud looked like over Nagasaki, about a 20 kiloton bomb, and this is what Nagasaki looked like. So it's not only nuclear weapons, atomic bombs that can cause cities to burn. In 1906, not far from where a lot of you at Stanford are right now, there was an earthquake, and it caused a fire in San Francisco. Jack London, the famous author, wrote an article in Collier's about it. Within an hour after the earthquake shock, the smoke of San Francisco's burning was a lurid tower visible 100 miles away. And for 3 days and nights, this lurid tower swayed in the sky, reddening the sun, darkening the day, and filling the land with smoke. I watched the vast conflagration from out in the bay. It was dead calm, not a flicker of wind stirred. Yet from every side, wind was pouring in upon the doomed city. East, west, north, and south, strong winds were blowing upon the doomed city. The heated air rising made an enormous suck. Thus did the fire of itself build its own colossal chimney through the atmosphere. And this is what San Francisco looked like afterwards. So there are 13,000 nuclear weapons on the planet today. This is a picture done by the Nagasaki University. And this wedge is the US, this wedge is Russia, and these are the other 7 countries. Let me blow this up for you. The US and Russia each have about 6,000 weapons, and all the other countries have a couple hundred, although the UK has just announced plans to add a little bit to their arsenal. And so some of them are on at sea on submarines, some are on land, some are on airplanes. So recently, in the last 15 years, we were looking at what would happen if say, some of these new countries like India and Pakistan had a nuclear war. After all, along the Kashmiri border, there are always skirmishes there. And this is a picture from the space station of the border between India and Pakistan. And all these lights here are big cities, huge cities. And some of them you never even heard about, with 4 million cities, Faisalabad. Yet, if they burn, they would produce large amounts of smoke. So we asked the question, what if India and Pakistan had a nuclear war? Imagine a skirmish in Kashmir, and then due to poor communication, misunderstanding, panic, and fear, a nuclear war started. And when we did this 15 years ago, each one had about 100 nuclear weapons, and we thought the easiest one for them to make would be a Hiroshima size. So what would happen if each one used half their arsenal? So there were 15 kiloton Hiroshima-sized bombs put on India and put on Pakistan. What would be the climate impact? And so this is a little movie I made of where the smoke would go. And on the left, we live in the troposphere down here. This black line is the tropopause, and the smoke would be heated by the sun, lofted up into the stratosphere where there's no rain to wash it out, and last for years being blown around the world. And this would cause climate change. If you plot the global warming we all know and love here, and this is the instant climate change you would get from this. Temperatures would plummet by more than 1 degree Celsius, a couple degrees Fahrenheit, and it would be climate change unprecedented in recorded human history, colder than the Little Ice Age. And so what would that mean? Well, a couple other groups with different climate models did the same calculation, 5 million tons of smoke, and they got the same effect. And Mike Mills had better graphics, so let me show you his movie. This is the smoke, the troposphere, and this is March, so in a random year, and so the northern hemisphere has sunlight, and it's heating the smoke, lifting it up to the stratopause. And then as the year goes on, the sun moves over to the southern hemisphere, and the smoke goes there. And this is a logarithmic scale, so there's almost no smoke at all going down here. It will last for the folding time is 7 years, for a long time. But it's much worse than that. This is a Trident submarine. The US has 14 of them, and each one has about 100 nuclear weapons, and they're 100 or 500 kilotons, not 15. So each one is 1,000 Hiroshimas, and that's about half of our arsenal. So we have about 25,000 Hiroshimas, and Russia has the same, so that's 50,000 Hiroshimas, not 100 Hiroshimas. What would happen if there was a war between the US and Russia? And that could happen by mistake, by a crazy person, by computer failure, by panic. So we did a climate model simulation of 50 or 150 million tons of smoke, which would be produced by this. And what could produce 150 million tons of smoke? Well, that was the standard scenario of 30 years ago. But even using a third of the arsenals from 30 years ago, there was 9 weapons for every potential target. So even today, we could produce that much smoke. And here's a movie of the smoke. It's much thicker, and again, it would cover the world and last for years. And so let's take this is a year later, the temperature change. So these temperatures are 20, 30 degrees Celsius, 50 degrees Fahrenheit, colder than normal in the summer. Let's take a place in the Ukraine where the Russian wheat belt, and look at how the temperature would change. So this is 2 years, and the black line is this minimum temperature at that point, and without nuclear war, and it would get up to 20, 25 degrees Celsius, 70, 80 degrees Fahrenheit in the summertime, but go below freezing in the winter. But if you put the smoke in here, temperatures rapidly get below freezing and stay below freezing for at least 2 years. And so clearly there'd be no agriculture there or in any place in the middle latitudes where we grow our food, and the world would starve to death. If I plot this now on the observed temperature change. Now I've got to change the scale, and temperatures for 50 or 150 million tons of smoke would get several degrees colder. And just to remind you, during the last ice age, when there were mile-thick ice sheets covering North America, the global average temperature was about -5 Celsius, colder than today. So this was be at instant ice age temperatures. How would this affect agriculture? Well, we've been doing some calculations, and clearly it would be dark, it would be colder, so the plants would grow more slowly, the frost-free growing season would be shorter, it would take longer for times to reach maturation, and there might be cold spells like there were in the year without a summer after the Tambora eruption that Reagan mentioned, where crops were killed in the summertime in New England, and less rain. And we've done calculations of all these effects, which I'll show you a couple calculations, but there's a lot of other things we haven't really been able to study yet. We're working on it. Toxic chemicals, no other plants to plant, no fuel, water, pesticides, distribution system, and ultraviolet radiation. So we looked at India-Pakistan conflicts nowadays, and before we did 5 million tons of smoke, but now we think with their larger arsenals and larger weapons, they could have maybe 27 million tons of smoke. So the temperature over land would get 6 degrees colder, not 2 degrees colder. And so really the effects could be much larger than what I showed you already. And we've looked at crop models, and this is, for example, for corn. This is how the corn would change in the years after a 5 teragram 5 million ton nuclear war in different places. Russia would have a 50% reduction of their production. Globally, it would be a 13% reduction for the first 5 years. But if they had more smoke, say 16 million tons, it would be a 34% reduction. And we've done this for the other major crops, soy, wheat, and rice, and for different scenarios. And it would be a catastrophic impact on agriculture for the world, using less than 1% of the current global arsenal on the other side of the world. What about, can you go fishing? So this is the ocean before, but afterwards, the ocean temperatures would change, the oceanic food chain would collapse, and there'd be storms along the coast because the temperature would cool more over the land and over the ocean. So that, and we've done calculations of how much fish there would be, and that really wouldn't solve the problem. We can't test this theory, obviously, in the real world, but we look at analogs, things that can inform us about it. And so the seasonal cycle, it gets cold in the winter. Why? There's less sunlight, the days are shorter. It gets cold at night. I've already showed you that cities can burn from so-called conventional bombs in World War II, firestorms, but also from nuclear bombs. And then what about the smoke and dust? Well, volcanic eruptions show us that particles can cover the whole world and cause cooling. It happens on Mars. The asteroid impact killed the dinosaurs. We have forest fires, Saharan dust. All these analogs help support this theory. And the same models we use to calculate the climate response, we use them on these things. For example, there were huge forest fires in Canada 3 years ago, and Australia a year ago, and they pumped smoke up into the stratosphere. Then the sun heated it and it rose up farther up in the stratosphere and lasts for a long time. And so our models simulate that. And for much more smoke from these fires, it would cause the same, gives us more confidence. So the conclusions, a nuclear war between any nuclear states using much less than 1% of the current arsenal would produce climate change unprecedented in human history. Such a small nuclear war would reduce food production by 10 to 40% for a decade. Nuclear winter theory is correct. The current arsenal can still produce nuclear winter, producing global famine. Nuclear winter could kill most of humanity. In a US-Russia nuclear war, more people could die in India or China than in the US or Russia, even if no bombs are dropped there. It will last for more than a decade. So there are some treaties that were signed to try and solve this problem. The Obama and Medvedev signed the New START Treaty and a bunch of other treaties. And this was just extended by Joe Biden to 2026. It limits the US and Russia to about 1,400 weapons each, but 1,550 weapons each. But that's still enough to produce nuclear winter. So the problem hasn't been solved. There have been treaties about where nuclear weapons can be. And so this is a map of the world. Everything blue has no nuclear weapons. There's none in the Southern Hemisphere. There's 1 country in the Western Hemisphere, 2 in Europe, and 6 in Asia that have nuclear weapons. the Treaty on Prohibition of Nuclear Weapons was put through the UN by the International Campaign to Abolish Nuclear Weapons in 2017. It just came into force in January, but the nuclear nations are trying to ignore it. We wrote a paper showing that if you say, I want my weapons for deterrence, really it's self-assured destruction, not mutual assured destruction. Because if one country attacks another one in a deterrent strike and they don't even retaliate, everybody in the first country dies from the climate response. So if you say I'm using my nuclear weapons for deterrence, you're acting like a suicide bomber. It's completely crazy. And nuclear weapons don't deter conventional attacks or cyber warfare or terrorists. All these examples of nuclear nations were attacked even though they had nuclear weapons. It didn't deter that. So let me, and there've been many incidences where we almost had a nuclear war. So what can we do? We could take the US land-based missiles off hair trigger alert, which are very unstable. We could give up the sole presidential authority to launch nuclear weapons. We could change our policy to no first use, and we could stand down our land-based missiles. So ICANN got the Nobel Peace Prize in 2017 for its work to draw attention to catastrophic humanitarian consequences, including our work, and to push through the treaty. And when Beatrice Finn accepted it, she said, the story of nuclear weapons will have an ending. It's up to us what the ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where our mutual destruction is only one impulsive tantrum away. So nuclear weapons can be used if they exist. A nuclear war could start tomorrow by accident, hackers, computer failure, bad sensors, or unstable leaders. Nuclear arsenals do not deter attacks from non-nuclear states, terrorists, or pandemics. The only way deterrence would work between nuclear states is if states believed other states were willing to kill themselves by using their weapons, and if there was no unintended use, and if deterrence lasted forever. The only way really to prevent a global catastrophe is to get rid of the nuclear weapons. So Carl Sagan, who was one of the people that worked on nuclear winter, said, for myself, I would far rather have a world in which the climatic catastrophe cannot happen, independent of the vicissitudes of leaders, institutions, and machines. This seems to me elementary planetary hygiene as well as elementary patriotism. And I agree. Elementary planetary hygiene demands we eliminate nuclear weapons much faster than the current pace. So I hope we learn from this that our planet ends up looking beautiful like this for a long time to come. And if you want more information, you can go to my website where we have all our papers and much more information, this PowerPoint, and lots of stuff. Thank you very much.
Thank you, Alan. I would like to start with one question, which is how much consensus is there about the climate models that you're using for nuclear winter scenarios? And how much should we be worried about within model uncertainty versus uncertainty about the models themselves?
We used a state-of-the-art model from 15 years ago to calculate nuclear winter, a NASA model. And then recently we used one from the National Center for Atmospheric Research, much more sophisticated, much higher resolution, and got exactly the same answer. And so nobody doubts that if you put that much smoke in the atmosphere, it would cause that much climate change. The real uncertainty is how much smoke would you get for a given scenario. We don't know how nuclear war would be fought. We don't know what the targets would be. That's secret. So we calculate how much climate change you would get from different amounts of smoke. And we know certainly there are scenarios where you could get that much smoke into the atmosphere.
Great. On one of your slides, I think on discussing agriculture, I think you mentioned that there would be no fuel or less fuel. One attendee was curious why that would be the case.
Well, how would you get fuel to the farms? How would you get the machinery to the farms? How would you get current technology working? You'd have to go out and farm by hand. You couldn't continue modern farming with the. Where would you get your gasoline for your tractors and parts for your tractors? The idea is that society would be so disrupted as was discussed by Joan this morning, not just the direct effects of the war, but complete collapse of international trade.
Makes sense. Another question is, what do you think the chances are that nuclear war poses a truly existential threat to humanity?
I should mention that that's what this conference is about. We can't think of any scenarios where it would kill all human beings. There would be some that would be lucky enough living at coastlines, maybe in the southern hemisphere, maybe in New Zealand, where there wouldn't be as much climate change because you'd be surrounded by an ocean and there'd be a lot of sheep and fish and maybe so probably people are very clever. There might be people that would be lucky enough and smart enough to figure out how to live, but it would be back to a caveman type existence. It wouldn't be a modern existence, but probably there have been super volcanic eruptions since there have been humans, like the Toba eruption in 74,000 years ago. And some people think that most humans died and we're all sort of descended, was a genetic bottleneck, and we're all descended from the few people that were lucky enough and smart enough to survive. And then we're all cousins starting then. But we don't think that it would kill all, it's hard to imagine a scenario where it would kill everybody.
Cool. All right. Well, I think that's all the time we have for today, but thank you so much, Dr. Robock.